Most of you, as I look at who's attending today, already know who Frank is. Frank Kozeliski is a PE and a fellow of the Institute and an honorary member of ACI. He is retired from his own ready mix company and is now a consultant and materials engineer for Michelle's Ready Mix. Frank chaired ACI 211, Proportioning Concrete, and has served many other ACI committees over his 50 years in the organization. And any of you who've had a chance to obtain one of Frank's concrete business cards, I have one myself, or concrete coaster, or concrete shot glass, or a concrete gavel, needs to know Frank. That's what you can do in your retirement years, but he did a lot in his working years and is still benefiting the industry by contributing. So it's all yours, sir.
Okay, thank you very much. I'm sorry for the technical difficulties. The initial curing of concrete, we talked about this a year ago when we were going to have this convention in Raleigh. And Calvin and I used to do troubleshooting seminars all the time. And we used to discuss this. We first started with our troubleshooting seminars with 35 millimeter camera or slides. Maybe some of you don't even know what those are. But then we went to PowerPoints, and I got to know Calvin he was the chair of 517, accelerated curing of concrete, and I looked up on my paperwork, and that was 33 years ago when I met him at ACI, since I've been a member for over 50 years. So this discussion about initial curing and specifications, he was really looking forward to that because he knew he was going to have a lot of business with people having trouble with concrete. Now, the initial curing, as we look at it on C31, I think is the most abused procedure when it comes to testing concrete. People leave the cylinders outside. They don't really take care of them. Colorado has set up a study where they're going to monitor these abused test cylinders. Most contractors and ready-mix people have indicated that 30% of the time, there's a problem on initial curing. It's not being done properly by others. So this is a major problem when it comes to ready-mix producers. Since I was a ready-mix producer, and now I'm back with my old company, trying to provide some of my input into helping them. Okay, this is where we were discussing that Colorado is studying and reporting improper curing of concrete, or improper curing of the specimens. And then ASTM C31, the volume that just came out, the paragraph talks about initial curing. It's on page 10. That cylinder should be stored up to 48 hours after molding to maintain the temperature. And now it is jumped again. In an environment that controls the loss of moisture. Note 13 is very simply written. Immersion in water may be the easiest method to maintain the moisture. And the temperatures. It's very simple, as you can see. Next slide. And as you continue on with C31, you got to identify the samples. Whose cylinders are these, and what is the compressive strength? I've run across situations where they had the wrong compressive strength, and this causes a lot of problems. Locate the concrete represented by the samples, the date, the time, who made them. I've had instances where they did not want to tell you who made them. You want to list the slump, the air content, temperature. These are very important items for the report. Down at the last part, it says curing. For standard curing method, report the initial method of curing and the maximum and minimum temperatures and the final curing. This last part is abused by many, many labs. Next section. And some of the notes that have come on the test reports says concrete specimens molded and cured in the field in accordance with C31. This is a very good requirement. Deviations. Specimens the specimen's environment was not monitored by the lab during initial curing. Basically, it means that they do not care what happens to the test specimens after they're cast. Things like this have been on reports over the years. On initial curing, I wonder, when CCL comes and inspects the labs, do they look at these test reports? I've discussed this with designers who hire the testing labs, and they come back to me and they say, well, Frank, they're professionals. They're all supposed to do it according to the latest ASTM additions. And it's like, well, sir, they're not doing it. And they say, well, they're a professional organization. They should be doing it. Next slide. So as I was putting this initial curing presentation together, I went to a job site in June, and I was surprised. It was about 80 miles from Gallup, out in the middle of nowhere. And there was a set of test specimens. This is a picture of them. And then I says, oh my gosh, they're doing it properly. And I put my thermometer in there, and it was 73 degrees. And it was the dirt outside. I hit with the infrared there. It was 113. I says, my gosh, this is hard to believe that they are testing this concrete and properly. The initial curing is being done properly. Next slide. So I found the test report, and I had to call up the lab to get the 28-day, because with this coronavirus, some labs are open, people are working from home, and we don't have the uniformity of getting all the test reports on time because some are working, some aren't. So the first thing I looked at was down there at the compressive strength. I said, oh my gosh, we had two sets, 28 days, 6,100, 6,400. I said, that's outstanding. And it's actually 40% higher. So as I was looking through there, I noticed the mix time to sample. I was in shock. 2.57 hours, 3.23, an average of about 3 hours. And I had this kind of compressive strength. So I went back and looked. The air temperature that day was about 85, low 54. Temperature on the reports was 63. We'd use super plasticizer to increase the slump to make it all workable. So I thought, I'll look and see what the cement efficiency is. And this was actually an 8-bag mix to get 4,500, because a lot of times they're not cured properly. So I realized that we were getting good PSI per pound of cementitious, whereas initial curing that is done improperly, you're going to get only half of that, 3 to 4 PSI per pound of cementitious. And it shocked me that this is what kind of strengths we were getting if the cylinders were properly cured like ASTM says to do. Next slide. So in summary, if concrete test specimens are properly cured, initially in water, temperature maintained with moisture, you get the strength. Delivery time factor is secondary. On the other hand, if the test specimens are not cured properly and strength is not made, folks are blaming the 90 minutes, that this is probably the reason for low strength. In my estimation, it's time to initially cure the concrete properly. If the mix is over 2 hours old and strength is made, there's no problem with time. Next slide. So as we go through this initial curing, this was a job I was at in 2007. Here's cylinders that were improperly cured, improperly marked. Next slide. And this is another, the little coolers that we have. There's no water in the coolers, no thermometers. And this improper initial curing, you can lose 1,000 PSI in 28 days. Next slide. This improper curing, this is another box on the left side where there was no water in there, no thermometer. Somebody damaged the cylinders and they had to go back in and remove concrete because there were strength problems. Now on the right, as you can see, these are 6x12, lost some moisture in the sun. There were strength problems on this job. It was a concrete box. And this happens most of the time on job sites, unless everybody tries to get the contractor, the test and lab, and the producer to make sure they take care of the cylinders properly. Next slide. Now this is a thermal tube curing box. This is one of our boxes that I had with Gallup Sand and Gravel about 20 years ago. You could put the water, you had the water in there. It kept the cylinders at 73 degrees. Yes, it cost me a few $1,000s at that time, but it was cheaper than tearing out concrete because the cylinders weren't properly cured and you were going to be blamed for it. The only problem we had with some of these boxes is that test and labs would not take their cylinders and put them in there because it was too far to set them up because the box has to be set up where you have power. Next slide. And the thermocure box, they have a couple of new ones. They hold the water, and this is a match cure. And this box is available. It's I've told them we need to look at using solar power to have batteries because most of these places out here in the reservation around Gallup, there's no electricity. So you have to have maybe some solar batteries. We have sun all the time, but it's another design that we need. Next slide. Then this is a master cure box by RPX. These are the folks that invented the IntelliRock loggers in maturity. They have this new box. We had a long discussion about using their new sensors. It's kind of like this computer. I had trouble getting online today, but I told them, I said, this was a little bit over my head trying to get their sensors to work because it's all being done remotely and with your phone. But this is some other people that do make a curing box to monitor your temperature of your test cylinders. Next slide. Now these people came up with a box. It weighs about 50 pounds and you can put about 20 4x8 cylinders in there. You can get a little bit of moisture. And the other day when they were advertising it, it was about $1,300. So there are boxes out there that can be used. Next slide. And this is very, very important. This is some work that was done in New Mexico a number of years ago. As you can see, if you don't cure the cylinders properly, you can lose 800 PSI at 28 days. So the first 24 hours it is going to indicate what your 28-day strengths are going to be. I've had a lot of people said, I wished I knew that a long time ago, because they've had concrete strength problems like that exposed to air. How many times have we been to a job site? We see the test cylinders. Basically, they're out there behind the outhouse because they were put in the shade. And then in the afternoon, the sun is shining on it and they're cooking the cylinders. So you're going to lose 1,000 PSI because of improper initial curing. Next slide. This is kind of a graph of the same numbers I just showed you. There's a big difference, and I put this in all of the submittals, that the cylinders need to be initially cured properly, immersed in water, or else we're going to lose 1,000 PSI compressive strength. Next slide. And then Karthik with National Ready Mix came up with the master spec. This is the latest, the 218 version. It says that the test and lab is going to provide this container for acceptance testing and verification to C31. It puts the responsibility on the test and lab to have a container that's going to maintain the 60, 80 degrees and be in water. And that the report's supposed to include the curing method, the minimum maximum temperature during the initial curing period. Next slide. Field testing has to be done by certified technicians, lab testing by certified technicians, and the contractor is going to provide a space for storage of initial curing, field curing of samples, and they're going to have to provide power at the project site, and you're supposed to have a pre-installation conference. This was in the master spec as of 2018. If anybody has run across this, I'd be interested to know if they're using it. Next slide. So then we come to winter, and this is real winter. This is like it's snowing outside right now here in Gallup. These are two methods that I came up with, very economical to cure the cylinders. Next slide. This is a power blanket on the left, and it's about $100, and it heats the water over 80 degrees. So you need to have a timer on your on the plug so it turns on and off to maintain the temperature between keep it less than 80 degrees. Like I said, this was one I came up with. I did not know how it was going to operate or how it would work, but we bought it, and it can work. Next slide. Proper initial curing on the left, as you can see, these coolers. The blue coolers had water in them. They put weight on them, and the heat of hydration, the test cylinders, the water would drop down to about 45 degrees. It didn't maintain the 60 to 80, but it's better than no curing at all. Now, the one on the right is a container I bought. I plugged it in, and I came back the next morning. All the cylinder, there's water on top, or there was ice on top of the water because the plug wasn't working. The water froze, but the cylinders were okay because the top quarter-inch of the water froze, and the cylinders were okay. Next slide. So that required me to find a method of checking the plugs. So it cost $6 to buy one of these things at the local lumber company. You plug it in, make sure the plugs have power before you plug anything in. Very simple, but it did worry me that we had frozen water on our test cylinders. Next slide. And then I monitored a lot of the water in these coolers. The command center, I bought some sensors from them. I'll be very honest with you. It challenges me to get all of this data to come up with nice fancy charts, because I'm not real into all these buttons and things to make it all work on your iPhone. Next slide. And this method of curing the cylinders is with the local tractor supply store. This is who manufactures them. It's about $50. And then you can go up to, they can have a 32-inch container that keeps the water for the animals from freezing. And their new buckets have that from 35 to 45 degrees, they turn on. So I'm going to have to look at this in the future to see about the temperature with these buckets for your animals. Next slide. And this was with the Tractor Supply and the probes I had from IntelliRock. I had probes where I could monitor the outside temperature and the temperature in the blue bucket there. And as you can see, we stayed between 60 and 80 degrees with the blue bucket and the change in the concrete temperature. Next slide. And then on the left is a Kestrel. It tells you the temperature and the relative humidity in the curing box. You can set this up with your iPhone. Put the sensor on top of the cylinder. They're not supposed to be in water. And I learned that at the one of the recent ACI conventions. It may have been the one we had in Canada. And then on the right is how we used to measure the high-low temperature before the electronics. It's an old-fashioned method of measuring the temperature with a high-low thermometer. I've had to explain to people how to use this because everything is digital. Next slide. And here's some more ideas. On the right is my smell test. When you test cylinders, do you ever smell them? Do you smell the super in there? On one time I had an ammonia smell. It was like, oh my gosh, what happened? The latest is on the right here is for $19. You can get a plug that when the air temperature drops to 35 degrees, the plug turns on. So it will keep your cylinders, I believe, from freezing. I found this just last week. Next slide. Then I was on vacation a number of years ago, New York City. I found a thermal tube curing box. Couldn't believe my eyes. Nobody had stolen it. Next slide. Next slide, Michelle. On this here is that ready-mix firms are trying to get very high-tech. This is some sensors from Duke City Ready Mix in Albuquerque, where they are monitoring all the information from the concrete and testing. Folks can't do initial curing properly. Something's wrong with this picture. Next slide. Next slide. And with those sensors, it tells us the size of the load, the slump, the temperature. They were using this for air to measure the air so that when they got to the job site, they knew what the air was. As you can see, it's very, very close because we're always chasing air. Next slide. In summary, proper curing can be done by folks testing concrete if they want to do it properly. Our computers are batching, measuring the concrete, all the ingredients. We can deliver it to the projects. Maybe the grade 1 certification technician can learn how to initially cure is being done. Give them a high-low thermometer, make it part of the grade 1 test. This way we can get performance mix designs or let the ready mix producer be in charge of quality control. Some labs can't handle the job of proper testing. Next slide. So with that, happy Halloween, Merry Christmas. And yes, that is a concrete snowman. My snowmen don't melt. Next slide. Next slide. And this presentation came from Gallup, New Mexico. Sorry about the technical difficulties, folks. Next slide. If you have any comments, questions, you can send them to me here.